size, as in mass, is actually quite, that's actually quite interesting. So Charon is 1/8 the mass of Pluto. That is the most massive satellite relative to its parent body in our solar system. So quite interesting, very, very interesting. So for comparison, the moon is 1/81 the mass of the Earth. So so the 1/8 is crazy, right? The moon is 1/81 the mass of the Earth. Charon is 1/8 the mass of Pluto. So it's almost like they're almost like a binary, right? I mean, which is fine. That's fine. Pluto and Charon are separated by a distance of only 20,000 kilometers. Wow, that's very small. Pluto and Charon are separated by a distance of only 20,000 kilometers and orbit their center of mass with a period of 6.4 days. So as you know, two bodies will kind of orbit around the combined center of mass. And so Pluto and Charon, which are only 20,000 kilometers apart from each other, will orbit their combined center of mass at a period of 6.4 days. And in this case, Charon is only 1/8 by only I mean it's 1/8 the mass of Pluto, which is quite a bit of mass compared to its parent body, parent planet body. So, you know, the center of mass is not super close to Pluto. It's closer to Pluto, but you know, somewhere in there, in the middle. Pluto and Charon both show brightness variations with a period of 6.4 days. That is, both Pluto and Charon have been tidally braked until they are in synchronous radiation. Oh my gosh! That's amazing. That's amazing. Pluto and Charon have been tidally braked. BRAKED, braked. So kind of like slowed until they are in synchronous rotation, because their masses are not so different, you know, and the distance between them also not very, very, very big. So the discovery of 2 additional small satellites of Pluto in the year 2005. So as recent as 2005, I guess it's not very recent to the younger people here, but as recent as 2005, we have 2 additional small satellites of Pluto, namely Nix and Hydra. Very cute names, Nix, N-I-X, Nix, and Hydra, H-Y-D-R-A. Enabled more accurate estimates. So by the way, once you discover more satellites of something, that actually helps you to get better estimates of the masses of things, such as the mass of Pluto. So this enabled the discovery of the 2 additional satellites, enabled more accurate estimates of the mass and thus the density of Pluto and Charon. The mean density of Pluto is 2,000 kilograms per meter cubed. So remember, we had talked about the sort of the densities of all the planets. Because Pluto is no longer considered one of the planets, it's considered a dwarf planet. It didn't really figure in that same table, but we had looked at all the densities. If you kind of go back to that live where we talked about the planets, the mean density of Pluto is 2,000 kilograms per meter cubed. That is meter cubed. So it's a density, meaning it's a mass over a volume. So the mass is in kilograms, the volume is in meters cubed or cubic meter. I had to think about that. the mean density of Pluto is 2,000 kilograms per meter cubed. That is actually less dense than our moon, by the way. So the mean density of Pluto is 2,000 kilograms per meter cubed, consistent with its being 70% rock and 30% ice. The lower density of Charon, which is 1,700 kilograms per meter cubed, indicates that it is probably half rock and half ice. Again, we have to spend time and resources on Charon if we want to figure out more details about it, but this is what we estimate at this time. Reese, how are you? I'm better, but I've been sick. Thank you so much for coming to the live. Although the surfaces of Pluto and Charon have been observed with the Hubble Space Telescope, that is, by the way, getting time on Hubble Space Telescope is, you know, something that a lot of astronomers, you know, want to do. If you want to get a PhD in astronomy, you might have to request time on the telescope, that is. The limits, so although the surfaces of Pluto and Charon have been observed with the Hubble, the limits on angular resolution mean that features smaller than a few hundred kilometers across cannot be seen. So even the Hubble will struggle to see things with a lot of resolution when they're so far away. Even at low resolution, however,